Hey guys, this is Jake Snyder. This is 2DS from DS, and I am currently on my way to work still, if you're watching the last video. And tomorrow I have a AP on a Stick type survey at a local residence hall for university, and we're going to be testing and doing RF design around Cisco's 1815W access point, which is their wall plate, current gen AC Wave 2 wall plate. And the idea here is the customer requirements are pretty straightforward. They want to be able to stream Netflix in the rooms of this residence hall, and from that they want to do it as inexpensively as possible. It is competitive with a couple other manufacturers, and so we're representing Cisco in this project. So we sat down and kind of ran the numbers and the shapes and sizes of the buildings and rooms, and we suspect the 1815W is going to be our pricing competitive. Some stuff going on up here. It looks like there's some accidents today. It's snowy out still, so yeah, so how we're approaching this. So our design methodology is kind of like this. We could do AP on a stick, and we could AP on a stick everywhere we want to go and verify we have coverage. We could do predictive and just approximate what the walls are. Instead, what we do is kind of a hybrid approach. We'll do some AP on a stick. We'll take some AP on a stick measurements that are representative of what the building looks like, and we'll use that to sanity check our model. So we could just take wall attenuation measurements and say, yeah, that's representative, but one of the things that I find is that when we do that, there's no sanity check of that number, right? So if I go measure a bunch of walls and I just take those values and plug them into my RF design software of choice, for us that's heck of how. If I go plug that in, how do I know that predictive model now is representative of our building, and that things are going to behave the way I anticipated they would? And the answer is there isn't. And it's part of the reason why validation is so important, is because I took some measurements, which is empirical data, but I have no way to sanity check that empirical data after the fact. So our approach is we survey out like an AP on a stick, but when we build our predictive models, I've got a whole bunch of data points, and if you do it in Ekahau, we trim back our channels in order to increase our rate of data collection. So I'm only capturing one channel. I can collect a lot of data points. Now I can take data points across those walls, pick a number of them, find my mins and maxes, and find what I think is a good value to start with. And then we'll draw our walls, we'll do our stuff, and when we're done, I'm going to take, and this is part of the reason why we are pretty careful about our survey AP configuration. What I'll do is I'll actually, in the SSID name, we'll set it's this many dB or milliwatts, it's this channel, it's these types of things. And what we'll do is we'll actually take a predictive or simulated AP and put it back in that same spot, same orientation, same height, all those things, and verify that our predictive cell looks like our real cell. Not exactly, but as long as it's close, we can tell that our model is representative of our design, and the actual our model and our design is representative of what's in the building. And so that way, when I'm done, I have a point where I can go back and say, well, if I did this and the building's moderately accurate, if I put the same AP in the same spot, does it work? And that gives us the flexibility of knowing that we're close or in the ballpark. And there's been more than one occasion where a coworker has done a design, and I look at it and say, wow, that looks really dense. What did that first AP survey look like? And it's drastically different. and it's like we missed our sanity check. There's a reason we do it that way, and it's to make sure that we're close. And so tomorrow we're going to go to this residence hall. Today it's a tower, so it's a round tower, and they've got rooms around the outside and APs in the middle. And right now the APs are in the middle as well, and it's a residence hall built back when nuclear bombs were a thing, and therefore it was kind of designed to be a protective building. We see that a lot up here in the Pacific Northwest. Lights on, police officers going by here. But we see that a fair amount, and one of the things that we have to deal with is when you put, when your buildings have, these really heavy attenuation materials, putting the APs in the halls tends to do not good things to the RF. And I've got a blog post up on the Transmit Feller site on hallway design nightmares and things that we have to deal with, and those things just become so much harder when we have these heavy, high attenuation building materials like we see in residence halls. So it'll be interesting trying to figure out how many 1815Ws we're going to need for this design, and try to go win this bid. So that's kind of our design methodology in terms of AP on a stick and predictive site surveying and how we're going to approach it. And hope you guys found that interesting, and please subscribe if you like what you see. Thanks everybody, have a good day.